This is Mario with MI Microflight, and this is my quarter scale CAD go-kart that I've been working on and off here. It's all aluminum, quarter inch outside diameter aluminum. I was going to weld this, but it was more effort to weld it, so I decided to make all these connectors 3D printed. They are bolt-on connectors. The only thing with this is that you have to drill right through the aluminum tubing, something that has been my pet peeve, when building models. But I decided to do that here because just the frame is in the connectors, the way I designed them, they just lend themselves just fine, doing it this way right here, going with the through screw right through the wall of the aluminum. I'm still working on the foot rests. This is a part that I came up with recently, and so I've been I'm not sure if I'm going to keep that part there, but it does have a dual function. It not only clamps onto this bar right here, but it also acts as the pivot point for the steering column, and it doubles up as the footrest bearing block support. You can see those footrests there, and I have doubles there because I've been, like I said, I've been working on and off and tweaking this. So I guess we can remove one of these so it's a little more clear. Let's remove this guy right here. There we go. And so these still have some parts to be added. The linkages to the brakes and to the throttle control. Of course, this will be electric. And being a scale model, it'll use a brushless motor, so I don't need throttle control here, except the speed control itself will be throttle, but I will mimic all these connections here just to keep it true to the full-size alley cat. Bending these tubing was a little tricky, and you can see my video on my bender that I did, and in some of the early pictures of the actual frame. But I wanted to do this video more on the CAD version and just show how I approach this particular model here. You can see all the parts that are done here. The wheel, I did it as one piece, but I didn't like the supports, as you need supports on this part underneath. So that was a part. That was this part right here, and you can see how ugly the the underneath of this is, and it's not quite round on the wheel itself, on the ring. So I decided to make that as a two-piece part, and that's what you're seeing here. And this piece right here prints separately than the ring itself. That's why I have the ring here and this part right here. So when I made STL files for these parts, I made them as separate pieces, and you can see the interlocking areas here of the wheel. So that's what I've been working on. And now let's just look at the model itself here. My table's quite cluttered here because I tend to design my model on CAD and then have this right in front of me as I'm working, as I'm tweaking things. But you can see some of the parts in real the physical form. Here's the steering column that I was showing a little while ago. This is a brand new part. It's a little bit longer, and I just finished redoing this section right here because I wanted the alley cat to have these angled sections here. Before it was just straight, straight through, and I don't like it. So I angled these parts, and I had to shorten this the distance of this front axle support. So that's been reduced, and now I have the right proportions there. This is quarter scale, like I was saying. This aluminum sort of pan type seat, I have to also work on that because I think I need to shorten this a little bit more so that I can bring it a little bit more forward. It'll give me more room here for the motor support. This is going to have a brushless motor. Those are the wheels, as I was saying. These are just pieces of plate mat that have been joined together. I have another tool that I designed to do the cutting of this with more precision. I put that on the drill press, and it cuts perfect rings for me that I can use them as my tires. does the wheel. I'm still working on the hubs for the wheels. Right now it's just a mock-up right now, and I'm also working on these bearing blocks. These blocks are going to be have some heavy-duty ball bearings, miniature ball bearings, of course, and then the shaft will ride on those bearings, as well as the wheel at the front here will also have some ball bearings embedded into the hub of the wheel. So right now it's just this is my first take of this wheel hub, but the next one's going to have provisions for direct insert ball bearings right on the hub itself, so it'll spin nice and free on the axle, which is just a bolt that attaches to this part right here. These have been beefed up as well. This part, all these sections were beefed up from the original ones, because the original ones were just quick and dirty way. Well, not so dirty, because this got to be designed on CAD, So that was one of my first ones. And as you can see, it's got sort of an angle bracket, but it was too thin. And so when I decided to update this, make it better, I went to this part right here. But these parts were still too thin, these brackets right here, and so I decided to beef that up, and now this bracket is pretty beefy. The only thing I think I'm going to do here is just make it into an L shape. Just put a piece of angled geometry here from there to there, just to support this part, make it like a shelf bracket, so it doesn't have any tendency of breaking, if we put too much pressure vertically. Other than that, I think this part is done. I made these parts originally round, but I ended up making them a little more tubular, not tubular, but rather squarish with rounded corners, just so that it would be a little more beefier. This section right here, we'll get a pan, a plate, an aluminum plate that will mate with this seat right here. So you can see these are angled connectors here, and this is for this tube here that's going to fit right there. I have to drill holes through there so it retains itself, and pretty much here's the new wheel. So I was explaining, in 2 pieces. I painted this one black. I could have painted this in black, but since I was painting all parts with the same PLA, I just decided to paint this one, and I just joined that last night with CA glue, and it's quite a tight fit, so that it retains itself in the go-kart. So the new brackets for the rear axle are going to be these guys right here, and you can see how it has that step there, and that's for a ball bearing. And inside these are quite heavy ball bearings, not heavy, but they are a little bit larger than what you would use for a 1/4 inch shaft. But I decided to use these because I have a ton of these ball bearings that I bought for helicopters, for things that I was doing, previous projects that I was working on before. And I also use these for auto gyros. I use these ball bearings for a lot of things that size. And so I decided to make an insert for my shaft. So the shaft is going to go right through here, and this insert right here will go into the ball bearing, because the ball bearing is, I believe it's 10 millimeters inside the diameter on these ball bearings. They're very nice ball bearings, and once that ball bearing is there, it'll be super nice. And I will do the same with the same size ball bearings, because I have a lot of them on the wheel, on the hub itself. So I have to build that geometry there, so that it'll accept that geometry there, so that we can just pop a couple ball bearings, one through the front here and one at the back, and that'll be also that'll have an insert, for the screw, and that'll attach right here, so that'll provide the nice spinning wheel, with ball bearings on the wheel itself. These don't need the ball bearings on the wheels, given that the whole shaft is live, and the whole shaft needs to spin with the wheels. So this is where I'm at. I need to make a bracket right here for this tube right here. You can see this bracket right here was previously welded. I tried welding with aluminum, some aluminum brazing rods, and it took so long. It was a bit messy. It took so long, and it's just not worth, in my opinion, Um, there are people that weld things that are really well good at welding. They've been welding, models. They're working with steel rods and brass and copper, and you haven't seen too many aluminum, because aluminum it's quite tricky to weld. You got to have the parts super clean. You have to, you have to scratch the part, and it's got to be super clean in order for the flux to work, with the soldering or the welding rods. Otherwise, it just doesn't work that easy. It is doable, but I don't want to spend the time, because I spent a good maybe half hour just on one weld, trying to get cleaned up, and preparation and welding. It's just not time effective, and for the stuff that I like to do. So I get much better effect, much better results, I should say, doing it this way. And it looks very spiffy, and it's very easy, and anybody can do this, except for the bending, which is a little bit tricky to do the bending. But if you stick, with just straight lines, it's with these connectors, it's super easy. um, so yeah, I'll keep working on this on and off. I've been working on some other projects. I've been cleaning some of my machines. I have machines that need rebuilding in my shop, so I'll be showing some of those videos. My keyboard, my Yamaha keyboard, also needs work. So many years that I've been using this equipment, these tools that they do wear out after a while, and so I have to rebuild all my not all my equipment, but most of the heavily used equipment in my shop, such as lathes, mills, uh, bandsaws, drill presses. So I'm going to be doing that, and I'll be showing that in some other videos here. But this is one of the fun projects that I like working on when I get the itch, to just to get away from the craziness of this world. This is Mario once again. Stay tuned for more. Thank you for watching.